The question of whether there is life on other planets has concerned mankind since ancient times, as soon as people realized that they live on a ball that flies in infinite space around its star, called the Sun. People have tried to catch signals from extraterrestrial civilizations by using huge radio telescopes, by launching probes and rovers to the nearest planets to Earth, such as Mars and Venus. Sent, also, a lander to Saturn's satellite Titan. Mars is one of the coldest planets in the solar system, with an average temperature of 63 degrees Celsius, 63 degrees Fahrenheit, which can drop to 125 degrees Celsius, 193 degrees Fahrenheit in winter. Its atmosphere, composed mostly of carbon dioxide, is too rarefied to protect it from solar radiation. Although water is present on Mars, it is mostly in a frozen state, forming polar caps on the surface and hidden stores of ice beneath. A team of computational sociology experts from George Mason University found through modeling that 22 people is the minimum number needed to establish a human colony on Mars. As people around the world ponder the possibility of one day sending humans to Mars and then later establishing a colony, scientists are exploring ways to overcome obstacles to such goals. According to the team, one factor to consider is determining how many people a Martian colony can support and what types of people are required. The team created a model that simulates a colony on Mars, paying particular attention to how many people it takes to create a viable colony, as well as the characteristics that would likely contribute to the success of such a colony. To this end, they used data from past attempts, such as questionnaires filled out by groups aboard the International Space Station or by those who have lived in the Arctic for months. They also tried to take into account known personality traits such as stress tolerance, social skills, and degree of neuroticism. The research team ran 5 simulations, each modeling 28 Earth years of colony life, while changing factors between launches, such as the number of people in the Martian colony. They found that 22 people was the minimum number needed. They also found that people with pleasing personality characteristics. However, Mars has a very thin atmosphere that consists of carbon dioxide, almost. This atmosphere cannot protect the planet's surface from solar radiation and other cosmic radiation. The planet has a very weak magnetic field, which causes Mars's atmosphere to slowly escape into space. The same process exists on Earth, but our atmosphere recovers its own component many times faster than it escapes into space, thanks to the magnetic field, among other things. Also, that under the surface of the planet may be preserved water just as it is on Earth, when, for example, we use water in wells. So on Mars, there may be life in that water. But according to the landscape, which we broadcast in photos from Mars' automatic interplanetary stations and rovers, we can conclude that on Mars there was a global catastrophe that killed all life on this planet. And the life there should have been, because there was a lot of water, there were riverbeds, or these are traces of giant floods of a different nature. And the landscape itself is a consequence of water erosion, a section with a water flow trace about 100 kilometer long, 62 miles. These may not be rivers, but highly eroded faults or flows from mud volcanoes. The most obvious trace of what happened is the giant fault, canyon of the Marina Valley. The length of the canyon is 4,500 kilometers, 2,800 miles, and depth up to 11 kilometers, 7 miles. West of the canyon are 5 huge volcanoes, Tharsis region, together with the highest one, the Olympus volcano. 3 of the volcanoes are in a line, like the Hawaiian Islands on Earth: Mount Asclepius, north, Mount Peacock, and Mount Arsia, south. Their heights range from 14 to 18 kilometers, 8 to 11 miles. Northeast of Olympus is the vast shield volcano Alba, only 1.5 kilometers high, 0.9 miles above the plateau, but in diameter, the mass is spread to 1,300 kilometers, 808 miles. Magma does not spread like this, high viscosity. Perhaps it is a mud volcano, and it was spreading mud flows. The cone itself is not black from basalt. The height of the volcano Olympus, 26 kilometers, 16 miles. There are a total of 20 volcanoes on Mars, and 5 of them are huge shield volcanoes, with a large diameter at the base. The volcanoes are located in a region of Mars called the Tharsis and Phocida provinces, which are higher than the rest of the surface. An elevation map of this hemisphere of Mars. You can see traces of some streams that once flowed down from the Tharsis province. It's possible that these mountains are said to be mud volcanoes, and the Tharsis Plateau is sediment from mud outcrops. The masses were deposited, and the water flowed below. A giant Martian flood occurred. If the terrestrial planets are similar in internal structure, then the same thing happened on Earth. Traces and volcanoes abound. At its base, the volcano Olympus has precipitous slopes up to 7 kilometers 4 miles high. If it was spewing lava or mud flows, it wouldn't have left such steep slopes. The masses would have flowed away. Scientists have no definite opinion on this, but there is an assumption that the volcano washed the ocean. The water washed up its slopes and formed these steep precipices, or those streams that flowed from the province of Tharsis washed up the foot of Olympus. In 2020, a study was published that says the water flow marks on Mars were made by flows from mud volcanoes. But what caused such a massive phenomenon? If we look across the hemisphere from the volcanic plateau, we see a huge depression. The assumption is that a large object fell here. Perhaps there was another Martian moon in orbit besides Phobos and Deimos. During the fall, the shockwave passed through the entire thickness of the planet and produced fractures in the crust on the opposite side. The Mariner Valley and giant volcanoes were formed. Now, large-scale volcanic processes are not observed. Water on Mars has evaporated, probably due to the loss of the main volume of the atmosphere. And the planet doesn't seem to be showing any signs of life. But some facts say that some processes are still going on. There are photos of the AMS, which studied the surface of Mars, where you can see plumes from the Martian volcanoes, whether it's clouds or ash from an eruption. According to scientists' observations, the clouds appear at the same time about once every 687 days. As you know, on July 20th, 2023, the Perseverance rover successfully delivered soil samples from Mars to Earth. This event was a milestone in the exploration of Mars and the search for extraterrestrial life. Scientists have already begun studying the samples using a variety of techniques, including microscopy, mass spectrometry, and genetic testing. The results are encouraging, but they are not definitive proof of the existence of life on Mars. Organic molecules in soil samples from Mars serve as the building blocks of life, and they can form without biological activity, such as exposure to sunlight. Minerals have also been found that indicate the possible presence of liquid water in Mars's past. These findings support the hypothesis that conditions for life existed on this planet. Traces of bacteria found in the samples require further study to determine their origin and connection to Mars. The fact is that so far, when mankind is looking for extraterrestrial life forms, it is based on our form of life that evolved on Earth as a result of circumstances. That is, scientists are looking specifically for a carbon-based life form, and also they are guided by the Earth conditions of life, which include the presence of liquid water, acceptable temperatures for the existence of life, a dense atmosphere, the presence in this atmosphere of the necessary gases such as oxygen, nitrogen, and others that are in the atmosphere of the Earth. Suddenly, there is life with a different form of organization from Earth's. After all, even a carbon-based form of life can be different from the Earth's. It should be understood that even the carbon-based form of life organization existing on the Earth may be different on other cosmic bodies, because the conditions there are elementarily different from the Earth. If on the Earth, life has gone through hundreds of millions of years of evolution, then the same evolution has taken place on another potential planet, even on the basis of carbon. This means that at each stage of evolution, the environmental conditions on such a hypothetical planet could have changed, similarly as on Earth. Carbon-based life adapted to these changing conditions. By the way, initially, on Earth and on such a hypothetical planet, the form of carbon-based life could be the same. Or even our Earth and the hypothetical planet could have received life from outside, for example. Life on them could have been brought by comets or asteroids. The evidence that, even in our solar system, on the satellites of planets, or on the planets themselves, Mars or Titan in particular, there could be a carbon-based life form, is that a very large number of life forms exist on our Earth. These carbon-based life forms exist everywhere on Earth. Such life can be found both in completely cold oceans and practically at the very mouths of volcanoes and oceanic rifts where temperatures are off the charts. These are extreme conditions, and all of this may be evidence that carbon-based life may exist on other planets that we still consider uninhabitable.